Today let us start the new branch of mathematics called three-dimensional geometry. In three-dimensional geometry, we have seen in class 11th, in three-dimensional geometry, we will have to discuss the objects or the solids and the different types of solids and its volume and properties of the solids. And there, we will have to locate, first thing we have to do is, we have to locate the point in a space. So while locating the point, you know that in two-dimensional geometry, you can locate a point in a plane. So in a plane, when you locate a point, you require only two mutually perpendicular axes. One is called x-axis and the other one is called y-axis. So when we locate a point in a plane, what we do is P, let us take P12. So we consider the distance of the P from or perpendicular distance of P from y-axis, which is called a x-coordinate, that is 1. Similarly 2, the second number written in the ordered pair, 2 is the perpendicular distance of the point from x-axis. So that is called a y-coordinate. So or axis and ordinate. So these things we have seen in two-dimensional geometry. But here in three-dimensional geometry, to locate a point, in space. So it is not in a plane. So to locate a point in space, we require three perpendicular axes. So we will have to find out the distance of the point from three perpendicular axes. Now, last year also we have seen this in class 11th. How we get the three perpendicular axes? Like when three perpendicular planes intersect. This is one plane. This is another plane. This is the third plane. So these three perpendicular planes are mutually perpendicular planes. When they intersect, you see that what is the point of it, or what is the intersection? When the two planes intersect, we get a line. Okay. So these two planes, when it intersect, we get a line. Similarly, when these two planes intersect, we get this line. Similarly, these two planes, when it intersect, we get this line. And when the three mutually perpendicular planes intersect, we get three mutually perpendicular lines called x-axis, y-axis and z-axis. X-axis, y-axis and z-axis. Normally it's not possible to draw in a plane. So this is considered as x-axis, this is considered as y-axis, this is considered as z-axis. But please remember, the x-axis, y-axis and the z-axis are the three mutually perpendicular lines. Okay, so the point of intersection is called origin. And here to locate a point here, what we have to do is, we will have to take a distance. So we can name this as x-axis, this as y-axis and this as z-axis. So these three planes divide the whole plane into 8 equal portions. So this is the first, each portion is called octant. This is the first octant. In class 11 we have seen all this. This is only revision. So this is first octant, second octant, third octant, fourth octant. Again 5th, 6th, 7th, 8th. So like we have seen last year how to locate. Suppose if you want to locate a point somewhere here, we will have to find out the perpendicular distance of the point. If this is x-axis, this is y-axis, this plane is called xy plane. Similarly, this is y-axis and this is z-axis, means a plane representing this. This is called a y-z plane and this is x-z plane. And we have to locate a point here in space. We have to find out the perpendicular distance of the point from xy plane, y-z plane and z-x plane. So perpendicular distance of the point from z-y plane is called x-coordinate. Okay. Similarly, y-coordinate, z-coordinate. So these perpendicular distance you can measure from x-axis, y-axis, z-axis. Okay. X-axis, this is x-axis. x-axis, y-axis, z-axis. So this is called a x-coordinate, this triplet, which has got 3 numbers inside a bracket. It's called x-coordinate, y-coordinate and a z-coordinate. Actually, x-coordinate is a distance of the point from y-z plane. Y-coordinate means it is a distance, perpendicular distance of the point from x-z plane. So similarly, z-coordinate. So these things we have seen last year. Same way, suppose if 2 points in a plane are given, now you know how to find out the distance between the 2 points. We have a distance formula. Distance between the 2 points is equal to root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. And some application problems last year we have seen. Same way, in previous chapter, the vectors, we have seen the different form, what is meant by vector. So let us say a vector AB. If 2 points are given, what is meant by vector AB? So the vector AB, it is initial point of the vector AB is A and terminal point is B, and it is directed towards B. So this is the meaning that last year we have, previous chapter we have seen this. Vector AB, the representation, magnitude of vector AB, the position vector of the point P. And similarly, how to add the 2 vectors, subtract one vector from the other, then multiplication, that means dot product and scalar triple product, scalar dot product and vector product. So both the products we have seen in the previous chapter. Now we have to discuss in the new chapter, that is called 3-dimensional geometry. Here in class 12th, we are going to discuss the different forms of the equation of the straight line, which can be drawn in space. In class 11, we have seen different forms of the equations of the straight line which can be drawn in plane. But here we are going to discuss the different forms of the equations in space and different forms of the equations of the plane. So like this is one plane. So what is the equation of this plane? This is another plane. So different forms of the equations of the plane. So these 2 things we are going to discuss here. And before starting this plane and the straight line, I will have to define certain concepts, basic concepts. The first one is, like I have seen this, vector AB. So in the component form xi plus yj. This vector, if it is in the 2 dimension, we write it as xi plus yj, where x is called x component, y is called a y component. Suppose if we consider a vector in 3 dimension in space, we will have one more, that is zk. So with respect to z axis, so that is xi plus yj plus zk, where x is called x component, y is y component and z is z component. So this is about the vector. Now what is the magnitude of the vector AB? So in previous chapter there is a formula, that is x squared plus y squared plus z squared. So magnitude of vector AB is root of x squared plus y squared plus z squared. So this is about the vector. Now suppose that here in the plane, when we consider a straight line. So straight line means there is a particular position in a straight line. So when we consider a straight line in plane, in space, so we will have to consider, we have to define the straight line with respect to 3 mutually perpendicular axes. So how to define the straight line, or how to locate the straight line with respect to 3 mutually perpendicular axes? So for locating that straight line, we will have to learn new concept, that is called a direction cosines and direction ratios. Direction cosines and direction ratios. So here we can see that, suppose if a straight line is somewhere here. So let us consider a simple straight line which passes through origin. So this point is called the origin. So point of intersection of 3 mutually perpendicular axes is called the origin. So when we consider a straight line in space which passes through origin, and if this line, this we have seen, this is called the first octant. First octant, you can see that all the 3, x coordinate, y coordinate and z coordinate, or the octant is determined by the positive direction of x axis, y axis and z axis. That means first attempt you can see that x coordinate, y coordinate and z coordinates are positive. And let us consider this straight line passes through origin like this. And here we can measure the angle between the line and positive direction of x-axis. So this is x-axis, this is y-axis, this is z-axis. So when we measure the angle between the line and the positive direction of x-axis, this can be named as alpha. This is alpha, and similarly the line with the positive direction of y-axis, angle between the line and the positive direction of y-axis. So this can be measured and written as beta. And the third one is when we look at the same line, this line with the angle between the line and the positive direction of z-axis. Please remember, this is x-axis, this is y-axis, and this is z-axis. We are going to consider like this. So the positive direction of z-axis is gamma. So alpha, beta, gamma are the three angles made by the line with the positive direction of x-axis, y-axis and z-axis. So these three angles are called direction angles. Direction angles. So these three angles, with these three angles, when you find out the cosine of these angles, cos alpha, cos beta, cos gamma. So cosine of these angles, cos alpha, cos beta, cos gamma, they are known as direction cosines. Direction cosines. And we normally use the letters L, M, N to represent the direction cosines. L means cosine of the angle made by the line with the positive direction of x-axis, and beta means, or M means direction cosine, cosine beta, cos beta. It is the cosine of the angle made by the line with the positive direction of y-axis. And similarly gamma means it is the positive angle made by the cosine of, not angle, cosine of the angle made by the line with the positive direction of z-axis. These three constants are called direction cosines. Actually it is unique. We consider the direction cosines are unique for a given line. But you can see that here, a simple line when we consider, this is called, let us consider this as x-axis. Just imagine the other side, the negative direction of x-axis also. Please imagine the positive direction of x-axis and the negative direction of x-axis. So when we measure this as alpha, angle between the line and the positive direction of, when we measure this as alpha, you can see that the other angle with the negative direction of x-axis, that is, what is this angle? It is 180 minus alpha. So this angle is 180 minus alpha. That also can be considered as a direction cosine. So in that case you get cos 180 minus alpha means you get a negative 180 minus alpha in the second quadrant, cos is negative, so negative L. So it can be, L can be positive L or negative L. So if it is directed towards this side, the line is directed towards this, because it is a straight line. So it can be directed towards this side or this side. So when it is directed towards this side, you can see that cos alpha, cos beta, cos gamma are the direction cosines. And if we consider the other direction of the line, it is minus cos alpha, minus cos beta, minus cos gamma. But so since the direction cosines are known as it is a unique set of numbers for one particular line, we always consider, whenever we say a line, we always consider it as a directed line. For a directed line, only one set of direction cosines. Is it clear? One set of direction cosines for a single line. Suppose if the line is not passing through origin. Now how will you make the angle between the line and the positive direction of x-axis? So in that case, what we do is, we will have to consider another, suppose that this is the straight line. This is the straight line. Anywhere in space, in any octant. But you can consider a parallel line passing through origin. This is a straight line. So a parallel line passing through origin like this. So in that case, once if you consider a parallel line passing through origin, you can measure the angle between the line and the positive direction of x-axis. Alpha, positive direction of y-axis, beta, positive direction of z-axis called gamma. So they are direction cosines of this line. This line also make the angle direction angles as alpha, beta, gamma, the same. So cosine of the alpha, cos, beta, cos, gamma are called direction cosines of this line. So since we consider this as a directed line towards this side, the direction cosines are unique. For any particular line in a space, the direction cosines are unique. But the next topic is direction ratios. Direction ratios means any three numbers proportional to these three numbers are called direction ratios. Okay, so here element are the direction ratios. Direction cosines. And let us consider A, B, C are the direction ratios. So here L, M, N are direction cosines. You can see that when you multiply by L by a constant K, you get a new number called KL. So similarly, multiplied by the same constant K to M, you get a new number Km. B equal to Km. Similarly, C equal to Kn. So one set of numbers, the new numbers, which are proportional to direction cosines are called direction ratios. So, instead of K, suppose that when we can take K as 100, you get one set of direction ratios. Instead of K as 100, if you take K as minus 100, you get another set of direction ratios. So, any three numbers which are proportional to direction cosines are called direction ratios. Is it clear? Now, these three numbers, direction cosines of a line means there are infinitely many set of numbers can be obtained. But for direction cosines are unique, direction ratios are infinite, it can be infinitely many set of numbers. So, for a line, there are infinitely many set of direction ratios, but unique set of direction cosines. There is a relation. Next is there is a relation between the direction cosines and the direction ratios. Now before that, let us again revise the small topic, that is direction cosines and direction ratios. Direction cosines and direction ratios for a particular line or a located line in the space means it is the angle made by the line with the positive direction of x-axis is called the direction alpha. Angle made by the line with the positive direction of y-axis is called beta. Angle made by the line with the positive direction of z-axis is called gamma. This alpha, beta, gamma are called direction angles. Then cosine of these direction angles are called direction cosines. We represent we use LMN to represent the direction cosines. So L equal to cos alpha, M equal to cos gamma, and N equal to cos beta, and N equal to cos gamma. Then once if you can see that the direction cosines of a given line is unique, but any three numbers which are proportional to direction cosines are called direction ratios. So there are infinitely many set of direction ratios we get for a given line. Is it clear? Now let us move to the next topic, that is when three numbers, or how to represent the direction, how to find out the direction cosines when direction ratios are given, and how to find out the direction ratios when direction cosines are given. Say example, if L, M, N are the given three numbers, it's given as direction cosines. So for getting the direction cosines. Now for getting the direction ratios, you have to simply multiply any one particular constant to L. So let us take 2L, 2M and 2N. So this is called a direction ratios. So direction cosines are given. To get the direction ratios, you have to simply multiply one constant and get the one set of direction ratios. Similarly, you can get the infinite set of direction ratios. But the other side, suppose if direction ratios are given, direction ratios are given. A, B and C. A, B and C are called 3 direction ratios. Now to get the corresponding direction cosines, we have, suppose that actually we write L as direction cosines, let us take it as LMN. L is equal to, A is equal to KL. Okay. B equal to Km. C equal to Kn. And since L squared, so when we square, consider the 3 equations and sum of the squares of these 3, adding the 3 equations. Sum of the squares of LHS equal to A squared plus B squared plus C squared, which is equal to, similarly, sum of the squares of the RHS, it becomes K squared into L squared plus M squared plus N squared. But there is a result, L squared in vectors we have seen L squared plus M squared plus N squared as 1. So therefore, K squared equal to A squared plus B squared plus C squared, or K equal to plus or minus root of A squared plus B squared plus C squared. K as plus or minus root of A squared plus B squared plus C squared. So therefore, from here we can substitute and find out the value L as A by K. So from here, L equal to A by K. A equal to direction ratio A equal to KL. So from here L is equal to A by K. So replacing K as root of A squared plus B squared plus C squared, we get A divided by root of A squared plus B squared plus C squared. So since we are considering direction cosine, it is a directed line. So only one set of direction ratios we have to consider. So you consider plus root of A squared plus B squared plus C squared. So when we consider minus root of A squared plus B squared plus C squared, you will get another set of direction cosines when the direction of the line is in the opposite. Instead of this side, the beginning I explained, instead of this side, when we consider the line towards the other side, direction is towards the other side, you get negative of. But we consider the directed line and therefore only one set of direction cosine, that is A by root of A squared plus B squared plus C squared. Similarly, from the second equation, B is equal to Km. Or M is equal to B divided by K, which is equal to B divided by root of A squared plus B squared plus C squared. Okay. Similarly, N is equal to C divided by K, which is equal to C divided by root of A squared plus B squared plus C squared. So this is the method, these are the formula we use when the direction ratios are given to find out the direction cosines. Is it clear? So direction cosines are unique. So that direction, when the direction ratios A, B, C are given, how to find out the direction cosines? So the L is equal to A divided by root of A squared plus B squared plus C squared, and M is equal to B divided by root of A squared plus B squared plus C squared, and N is equal to C divided by root of A squared plus B squared plus C squared. So this is the way we consider when the direction cosines, direction cosines are given, how to find out the direction ratios? How to find out the direction ratios? Multiply any 3 numbers to direction cosines, you get direction ratios. But when the direction ratios are given, to find out the direction cosines, we can use this formula L as A divided by root of A squared plus B squared plus C squared, and M as B divided by N as C divided by. Is it clear? So now let us move to the different forms of the equations of the straight line. In straight line, we have seen in space when we consider a straight line. So simply you cannot draw a line in the space. So with the two conditions you can locate a line in space. The first condition is, suppose if a point is given, a point in the space is given, here also you cannot locate a line because you will be able to draw infinitely many, first line, second line, third line, passing through the point you will be able to draw infinitely many lines. But to locate a particular line we require one more condition. So the condition, many conditions are there. So let us consider the first condition to locate the straight line in space as a parallel vector parallel to the line. Suppose that if this is the straight line and this is the parallel vector parallel to the line. So this is the line, here somewhere the point is given, and to locate the line passing through the point, another condition is given as another straight line or another vector parallel to the line. Suppose that if the vector is given like this is not the line. So you have to get the line by changing the line like this, and but it should pass through the same point. Now this is the required line. Okay. So to locate the position of the given line in space, we require two conditions. So the first condition is, here it is in this case, we are considering two conditions are, first condition is a point in space, and the second one is a vector parallel to the given line. So let us consider this as the given line L and a parallel vector B. Parallel vector B as, let us consider it as B1I plus B2J plus B3K. So this is the vector parallel to the given line, and a point on the line is given. That is, let us consider A, X1, Y1, Z1. A, X1, Y1, Z1 is the point on the line. And when we consider a point, it is fixed point. It's a fixed point. And to write the equation of the straight line, we always consider a variable point. So let us consider the variable point as Pxyz. So variable point on the line is Pxyz. What is the meaning of variable point? It can vary. It can occupy this position. Instead of this, it can be shifted here. So any point P occupies, since it's a variable point, any point on the straight line is a P. But this particular point, it is a fixed point. There you cannot change the position of A. It is fixed one, but variable point you can you can change the position. And while writing the equation of the straight line, here we get two forms of the equations of the straight line. One is called the vector form, and the other one is called the Cartesian form. Now let us derive the vector form first. In vector form, so here we will have to consider the position vector of A as A, vector A. And position vector of P as vector R, and this vector parallel vector is B. In previous chapter we have seen the position vector of the point A is a vector directed from origin to P, to A. That is same as A as OA. So from origin to this particular point A, that vector is called the position vector of the point A. Similarly, position vector of P means it is considered as R, but it is same as OP. So position vector of the point P is the vector directed from origin to P, OP. That is called the position vector of R. Now here we can see that the vector AP, when you consider the vector AP, so the vector AP is parallel to vector B. Vector AP is parallel according to the given condition. The given condition, what is the given condition? The straight line, the given required line is parallel to the vector B. Therefore, definitely when you consider any 2 points from the line, consider the vector AP. So AP will be parallel to vector B. So when AP parallel to vector B, according to the condition, AP equal to lambda into vector B. AP is equal to lambda into vector B. And the vector AP is same as position vector of the point P minus position vector of the point A equal to lambda B. Or position vector of the point P is considered as R. So R minus A equal to lambda B. Or from here R is equal to A plus lambda B. R is equal to A plus lambda B. So R equal to A plus lambda B is called the vector equation of the straight line passing through a point capital A with the position vector A and parallel to the vector B. This is the equation of the straight line. What is meant by this R? It is the position vector of the variable point P, X, Y, Z. So, this is the vector equation of the straight line passing through a point with the position vector A and parallel to a vector B, where R is the position vector of any point in the or variable point in the line. This is called the vector form of the equation of the straight line. And second one is, there is one more form that is called the Cartesian form of the equation of the straight line. In Cartesian form of the equation of the straight line, here we are going to derive the with respect to Cartesian coordinates. So here only thing R is considered as when R is the point position vector of the point P, then R is same as xi plus yj plus zk, because the coordinates of the point is x, y, z. So OP is same as xi plus yj plus zk. Similarly, position vector of the point A, since the coordinates are given as x1, y1, z1, in previous chapter vector we have seen this, OA is considered as x1i plus y1j plus z1k. Now, B is defined as b1i plus b2j plus b3k. So from the, let us use this vector form of the equation of the straight line. R is equal to A plus lambda B, that is same as xi plus x1i, sorry, xi plus yj plus zk equal to A plus, what is A? x1i plus y1j plus z1k plus, this is in one bracket, plus lambda into b1i plus b2j plus b3k. Now you can see that this vector equal to the RHS another vector. So two vectors are equal only when their corresponding components are equal. So x component, y component and z components. So let us equate the corresponding components and get the x as I component. X component, when you equate from LHS you get it as x here. And from the RHS when you equate, this becomes x1 plus lambda b1. x1 plus lambda b1. Similarly, y component, y is equal to y1 plus lambda b2. y1 plus lambda b2. Similarly, z is equal to z1 plus lambda b3. And from these three, you can see that the lambda is same. It's a constant. So lambda is same. So you can get an expression for lambda as x minus x1 by b1. x minus x1 by b1. Which is equal to the same lambda you get from the second equation, that is y minus y1 by b2, and from the same lambda you get from the third equation, that is z minus z1 by b3. So therefore this is known as the Cartesian form of the, so the three ratios are equal. So what is that ratio? It is same as the constant lambda.